Hello, my dear students. Last class I explained about different types of rain gauges. There are two types, recording and non-recording type rain gauges. Let us discuss the different types of recording rain gauges. There are three types, rain bucket type rain gauges, tipping bucket type rain gauges, and float type rain gauges. Let us discuss about rain type rain gauges. Self-recording gauges are used to determine rates of rainfall over short periods of time. The most common type of self-recording gauge is the rain bucket type. It is shown as shown in the figure. Here, the rain bucket rain gauge essentially consists of a receiver bucket supported by a spring or lever balance or any other weighing mechanism. The movement of the bucket due to its increasing weight is transmitted to a pen which traces the record on a clock driven chart. Okay, means it consists of a one storage pen which is weighed to record the mass. It weighs rain or snow which falls into a bucket set on a platform with a spring or lever balance. The increasing weight of the bucket and its contents are recorded on a chart. The record shows accumulation of precipitation. This is the principle of rain type rain gauges. Let us see the second one, tipping bucket gauges. The tipping bucket rain gauge is used for measurement of rainfall. It measures the rainfall with a least count of 1 mm and gives out 1 electrical pulse for every millimeter of rainfall. The most common one is a Stevens tipping bucket type rain gauge. It consists of a 300 mm diameter sharp edge receiver. At the end of the receiver is provided a funnel. A pair of buckets are pivoted under the funnel in such a way that when one bucket receives 0.25 mm of precipitation, it tips, discharging its contents into a container, bringing the other bucket under the funnel. Tipping of the bucket completes an electric circuit, causing the movement of pen to mark on clock-driven receiving drum, which carries a record sheet. The electric pulses generated due to the tipping of the buckets is recorded at the control room far away from the rain gauge station. Okay, here mainly tipping bucket rain gauge, it consists of a funnel that collects and channels the precipitation into a small seesaw-like container. After a preset amount of precipitation falls, the lever tips, dumping the collected water and sending an electrical signal. So, in this way, the water the precipitation can be measured. Okay, and the next one is the float recording rain gauge. Here, this is also called as siphon type rain gauge. The rise of flow with increasing catch of rainfall is recorded. Some gauges must be emptied manually while others are emptied automatically using self-starting siphons. In most gauges, oil or mercury is the flow and it is placed in the receiver, but in some cases the receiver rests on a bath of oil or mercury and the float measures the rise of oil or mercury displaced by the increasing weight of the receiver as the rainfall catch freezes. Float may get damaged by rainfall catch freezer, and already I have told it is also called as siphon type. Here, the working of a float or a siphon type rain gauge is similar to the rain bucket type rain gauge. A funnel receives the rain water which is collected in a rectangular container. A float is provided at the bottom of the container. The float is raised as the water level rises in the container. Its movement being recorded by a pen moving on a recording drum actuated by the clock work. When the water level in the container rises so that the float touches the top, and the siphon comes into operation and releases the water. Thus, all the water in the box is drained out. Okay, and the precipitation can be calculated. Here, the more details are available in IS 5235 1969. Next, let us discuss about interpretation of precipitation data. There are different methods of interpretation of missing precipitation data. The first one is estimating missing precipitation data at a station. Second one is checking inconsistency in particular data at a station. And third one is averaging precipitation over an area. Let us see the first one, estimating missing precipitation data at a station. Sometimes it may not be possible to measure the rainfall at a particular measuring station due to the absence of the observer or instrument failure or any other reason. In that case, the prediction of the missing data can be made with the help of available data of nearby measuring stations using the following methods. The first one is the arithmetic mean method, second one is normal ratio method, and third one is inverse distance method. Let us discuss about the arithmetic mean method. According to this method, the missing rainfall Px of a station X is computed by simple arithmetic average of the rainfall at the nearby station in the following form. That is this form. Okay, P bar is equal to 1 by n of P1 plus P2 plus P3 till Pn, or you can write like this also, P of I and divided by n, where n is the number of rain gauges and P1, P2, Pn are the rainfall values obtained from n rain gauge stations within a catchment. Okay, sometimes this P bar, it is represented by PM also, that is nothing but precipitation at the missing location. Okay, and instead of 1, 2, 3, this one based on this PI is precipitation at index station 1, like that. P2 also different index stations. This is about arithmetic mean method. Means mainly you have to remember this formula to calculate the missing data. Okay. Second one, normal ratio method. In this method, the rainfall of the surrounding index stations are weighed by the ratio of normal annual rainfalls by using the following equation. This is the equation: 1 divided by n of P1 nx divided by n1 plus P2 nx divided by n2, like that till Pn nx divided by nn, or you can write nx divided by n outside, P1 divided by n1 plus P2 divided by n2 plus Pn divided by nn, where n1 into nn are normal annual rainfall of index stations, nx is normal annual rainfall of missing station, and n is number of index station. The above method is used when the normal annual precipitation of the index stations differ more than 10% of the missing station. Here also the data of at least 3 index stations should be available, and all these index stations should be evenly spaced. Okay, this is about normal ratio method, and here in the arithmetic method, this is mainly used for the following condition. That means the normal annual rainfall of the missing station is within 10% of the normal annual rainfall of the index stations, and also the data of at least 3 index stations should be available, and also the index station should be evenly spaced around the missing station and should be as close as possible. Okay, so this is about normal ratio method, and third one is inverse distance method. In this method, a set of rectangular coordinate axes are passed through the missing rain gauge station so that its coordinates are 0, 0. The coordinates xi, yi of each index station surrounding the missing station are found. The weightage, that is wi, of each index station is represented by the inverse of the square of its distance from the missing station and is given by wi is equal to 1 divided by di square, that is equal to 1 divided by xi square plus yi square. And so the missing rainfall data of the station X is then computed from this formula. Px is equal to Piwi divided by Wi. The above method gives good results and is therefore the most acceptable method for scientific analysis. However, the limitation of method is that it estimates missing rainfall between the highest and the lowest values of the index station. That is the one drawback of this method. Otherwise, this method is the most commonly used method for finding the missing rainfall data. I hope all of you understood. Thank you.